Okay, so we're going to go ahead and complete the square to solve some quadratic equations. So this, in order to complete the square, what I need to do is get the quadratic and the linear term on the left and the constants on the right. So I'm going to add 24 to both sides, and I will end up with k squared plus 11k is equal to 31. Okay. From here then, what I'm going to do is I'm going to take the coefficient of the linear term, the 11, I'm going to divide it in half, and I'll show this work over here. And then I'm going to square it. Now 11 over 2 is 5.5, so it doesn't work out nicely. It doesn't become an integer when I square it. So I'm just going to leave it as 11 over 2, and when I square it, I'm going to get 121 over 4. And then I'm going to go ahead and put that back into my problem. So I have k squared plus 11k's plus 121 over 4. And because I added 121 over 4 to the left side of my equation, I have to add it on the right side as well. Okay. So at this point I want to factor the left-hand side. It should be a perfect square trinomial because we just completed the square. So we created the trinomial so that happens. And all I'm going to do to factor it is say that I have k plus 11 over 2, that quantity, times k plus 11 over 2. It's always the 11 over 2, that number is always going to be this number that you have in the parentheses over here that you use to complete the square. Okay, so you don't even, you can mindlessly write it down. You don't even have to think about it. And then over on the right here, we have to add 31 and 121 over 4. So we need a common denominator, so I have to multiply 31 by 4, which is going to be 124 over 4, and add to that 121 over 4, and that's going to be 245 over 4. So I'm going to write that down right here. Alright, so let me clean this up a little bit, and then we'll continue from here. Alright, so I cleaned the screen up a little bit. I want to rewrite the k plus 11 over 2, that quantity, instead of writing it twice, I'm going to write it as the quantity squared. And I'm doing that so that I can take the square root of both sides of the equation in order to solve this equation. So I'm just rewriting that quantity squared, and then I'm going to go ahead and take the square root of both sides. And I have to remember that when I take the square root, I am going to put plus or minus in front of the square root sign there. Alright, so on the left I have k plus 11 over 2. Squaring and square roots cancel each other out, so I have that. And then I'm going to have plus or minus the square root of 245. Now if I, over 4, if I simplify the square root of 245, it becomes 7 times the square root of 5. And the square root of 4 is just 2. Whoops. So it would look like that. Alright, remember root 245, if I made a factor tree and pulled out groups of 2, that's how I'm getting that 7 root 5. So there were 2 7s underneath there and a 5. The 7 came out and the 5 stayed underneath is what happened. Alright, from here I have to get k by itself, so I'm going to subtract 11 from both sides, and that is going to give me k by itself, isolated, is equal to negative 11 over 2, because I subtracted it, plus or minus, plus or minus 7 root 5 all over 2. And then my last step here is, since I already have a common denominator of 2, is just to combine my numerators. So I have negative 11 plus or minus 7 root 5 all over 2. If I could add negative 11 and 7 root 5, I would, or subtract it, but you can't, so we're just going to leave it like that. Whoops. Alright, let's do one other problem here. Clear that. Alright, for the last problem, I am going to set it up the same way. I'm going to keep the quadratic term on the left, as well as the linear term. I'm going to add 59 to both sides. So I have 63. Alright, and when I'm completing the square, I can't have a coefficient larger than 1 on the r squared. So I'm going to divide each of these 3 terms by 3. And so I have r squared minus 4r is equal to 21. Okay, now I'm good. I can complete the square. So I'm going to divide negative 4 in half, and then I'm going to square it. So that gives me r squared minus 4r. Negative 4 divided in half is negative 2. And then when I square negative 2, that's positive 4. So I'm going to add 4 here and 4 here so that my equation stays balanced. The left side needs to be factored. That becomes the quantity r minus 2. And instead of writing it twice, I'm going to square it. And that's equal to 25. Alright, so at this point, we can take the square root of both sides. And don't forget to put plus or minus root 25. This one's going to work out nicer than the other one did. On the left, we have r minus 2. On the right, we have plus or minus 5. And then we have to add 2 to both sides to get r isolated. So we have r is equal to 2. It's positive because we added it. Plus or minus 5. And on the last problem, we stopped at that step. But we want to, we want to, rather than stopping at this step, we want to take 2 plus 5 and get that answer in 2 minus 5. So 2 plus 5 is 7. Or the other answer is 2 minus 5, which is negative 3. So that would be our entire answer right there. So just to remind you, for completing the square, you have to get the quadratic and linear term on the left, constants on the right. Make sure that the coefficient then of the r squared term, or the quadratic term, is 1, and you do that by dividing all of the terms by the same amount. Complete the square, factor, take the square root of both sides, and isolate your variable, and you'll get your 2 answers that way.